before we cover the two different types of chi-square tests, I want to talk to you about the chi-square distribution and certain properties of that distribution. All right, so this is new material for you. You haven't learned about in the lab. So here are some pretty color-coded distributions. All of them are chi-square distributions. They look radically different though, right? So if you look at the one that's, this yellow line here, kind of golden yellow line, that looks very, very different than this red line, all right? So that's kind of a unique thing about these chi-square distributions, is that not only is there an infinite number of them, but unlike the T distributions and F distributions, they can look very, very different from each other depending on sample size or degrees of freedom, okay? So, properties of these distributions: there are an infinite number of chi-square distributions, one for every degrees of freedom, which is basically saying one for every sample size, because remember that degrees of freedom are very closely tied to sample size. Another thing about, well, let me get to the other one. Next one, chi-squared cannot be negative. It should be obvious why it can't be negative. Chi-squared. These are squared numbers. So as you can see from this diagram, all right, they all start at 0. All right, they start at 0 and then they go to positive infinity. And the further out you are in terms of the chi-square value, because these are chi-square values, so 1, 2, 3, 4, these are all different values of chi-square. The larger your chi-square value, the more likely it will be significant, okay? But you cannot have negative numbers. And I've already mentioned the distribution goes from 0 to positive infinity. And some of these distributions actually approach a normal distribution. So if you look at this red one, I've stopped it at 6, right? A little bit more than 6. But if we were to continue out, you would see that it pretty much looks like it could be a normal distribution. All right, very much platykurtic, right? It's flatter than what we think of as the typical normal distribution. It's flatter than that. So it's platykurtic, but it's actually not quite normally distributed, even though it approaches that shape, okay? And that's going to be true as degrees of freedom increase. So if we look at these distributions, this yellow one here probably has a lower number of degrees of freedom, all right, than the red one, all right? And it's just because this one here, the gold one, is not anywhere close to being normally distributed. It's very positively skewed, which in comparison, this reddish one looks far more normally distributed. So we can conclude from just looking at the curves that golden curve has fewer degrees of freedom than the red curve. But they're both chi-square distributions.